candidate. Let's see the design thread girder. Here with the example sum. Okay, let me read the data that is given. We we got a data likewise design a deck welded thread girder. Design a deck type welded thread girder. In here a term called plate welded plate girder bridge. Suit the following that. Note down the word welded because the connection may be in this, it may be welded or we are going to design a welded plate girder bridge. Okay, data. They have given span of the girder 30 meters of 7.5 kilonewton meter. Equivalent live load for bending moment calculation. They have got 727 kilonewton. Likewise, equivalent live load of shear. Here it is for bending motivation. Here it is for shear calculation per track. It is 2907 kilonewton. The top of the rail level is 108. The rail slope for the embankment is 1.5:1 is to 1.25. And the foundation level is 100 and width of the apartment is 4 meters. They are asking something to do by designing. They are asking us to design the main thread girder with intermediate and bilateral bracing. They are asked and they are all the things that are to be designed for thread girders. And they are asking us to draw some of the following of 7. Half longitudinal elevation and half longitudinal, half plan at top and half plan at foundations, half cross section at center of span and half through abutments. Longitudinal elevation of main plate, cross section of main plate girder, plan of girder with lateral bracing, intermediate and bearing stiffeners. Scales for the drawing. Adopt rolled steel section and steel plates with an yield stress of 236 Newton per mm square conforming to IS 226, IRC 24. Okay, these are the data we have got to design a plate girder. Okay, as I said earlier, to start there are some steps to be followed like design principles. We are going to follow the same as I said earlier. Okay. For designing a welded thread girder, first step is data. Here we have come with the data. We got a effective span of 30 meters from itself and broad gauge 1676 mm mainline single track. This is a constant term we could find in terms of high score books. Okay, next is step 2, dead load. Dead load we have got as 7.5 kilonewton per meter. For dead load we are also got if we discuss design principles, there we could see a formula for that of dead load 0.2 L plus 1 kilonewton meter. 5 plus 7, that is nothing but 14.5. Okay, make a note of 14.5. Then now coming to live load. Live load with respect to bending moment, we have one data for both tracks. If you want the data per track, we have to divide by 2. So live load per girder of bending moment is 1360.5 kilonewton. Okay. Next, similarly for shear force, live load for shear force per track is this per girder. This okay. Okay, and I said before going to bending moments and shear forces, we have to calculate impact factor. Impact factor, which for the as we discussed earlier in design principles of thread girder design, we seen that for impact factor we have some rules set to be followed that are in table 1 of Steel railway bridges of argument, that's nothing but CDA, where I is equal to 0.371. It's a constant term you could use anywhere within impact factor. Okay. Next, with respect to impact factor, we are going to bending moments, designing of bending moments. Okay. Just go through. Bending moment due to live load. Dead load is nothing but WL square by 8. And this is 14.5. As I said earlier, in dead load, we got this by 30 is the span. 30 square by 8. That's nothing but WL square by 8. We are getting this term 1630 kilonewton dot meter. Okay, next coming to bending moment due to live load. In live load, we are getting this term 1363.5 WL by 8. We are getting this. Okay, bending moment due to impact on live load. Okay, I hope you all could remember this impact factor. Okay, this is impact factor. Impact factor for live is 0.372 into, here's the live load, 5113.125, and we get bending moment due to impact on live load. Next, total designing of bending moment is nothing but addition of all this is nothing but 8645 kilonewton meter. And please don't follow what's written in the textbook. 3645.2 kilonewton meter is wrong. It's 8645 kilonewton meter. Okay. Next, step 6. Step 6 is nothing but shear forces. In shear force, similar to bending moment, we should also calculate shear forces. Shear force due to dead load is nothing but WL by 2. Similarly, for live load is nothing but W by 2. Shear force due to impact on live load is nothing but similarly as we done in bending moment is 0.372 into 371.75 kilonewton. That's nothing but 272.21 kilonewton. The total shear would be around 1221. Okay. Now we are getting here a term bending moment is equal to 8645 kilonewton per kilonewton meter, and shear force is nothing but 1221.5 kilonewton. Okay. I hope you all understood what we have looked for right now. That is most important for designing plate girder of welded connection. It would be followed by next steps furtherly in the class for the classes. Please be conscious and have a practice of the design what we are recorded right now. Okay.